Hi class, this is lesson 8.5, properties of trapezoids and kites. So a trapezoid is a quadrilateral with at least one pair of parallel sides called bases. So a trapezoid has two pairs of base angles. For example, in our picture here, angle A and angle B are one pair of base angles because they touch the same base, and angles D and angle C are the second pair. So my base would be here and here, those are my two bases, and then A and B, angle A and angle B, that's one pair of base angles, angle D and angle C is the other pair. The non-parallel sides are the legs of the trapezoid. So this first example showed that CDEF is a trapezoid. In order to do that, we have to show that this side and this side are parallel. And to do that, we use slope. So we're going to find the slope of DE first, and then we're going to find the slope of CF as well. And if they're the same, that means my two lines are parallel. To find slope, I draw my fraction bar and my minus signs. I'm going to plug in point D, which is 1, 3, and point E, that's 4, 4. And then simplify. 3 minus 4 is 1, or negative 1. 1 minus 4 is negative 3, so that reduces to positive 1 over 3. The slope of line CF, I'm going to do my fraction bar and my minus sign again. Point C is 0, 0, so I'll plug those in. Point F is 6, 2, and if I subtract, I have negative 2 over negative 6, which again reduces to 1/3. So since these are the same, my two segments are parallel, so this is a trapezoid. On your own one says in example 1, show the coordinates of, suppose the coordinates of E are 7, 5. So that would be right up here. So suppose I have 7, 5 as my new E. It says what type of quadrilateral is CDEF? So now we need to find the slope of DE, our new slope of DE. And if it's still 1/3, then it will still be a trapezoid. So my point D is the point 1, 3. My new point E is 7, 5. And if I reduce that, I have negative 2 over negative 6, which reduces to positive 1/3. So since it's still the same, I still have a trapezoid. Let me move my page down. Excuse me, sorry about that. So now we're going to talk about an isosceles trapezoid. So an isosceles trapezoid is when the legs are congruent. So these two legs are congruent. That makes us have an isosceles trapezoid. So if a trapezoid is isosceles, then each pair of base angles is congruent. So in our picture here, if trapezoid ABCD is isosceles, then angle A is congruent to angle D, and angle B is congruent to angle C. Theorem 8.15 says if a trapezoid has a pair of congruent base angles, so if we know it's got one pair of congruent base angles, then it is an isosceles trapezoid. So if angle A is congruent to angle D, or if angle B is congruent to angle C, we only need one of them, then we know it's trapezoid ABCD is isosceles. Theorem 8.16 says a trapezoid is isosceles if and only if the diagonals are congruent. So trapezoid ABCD is isosceles if and only if segment AC, the distance from A to C, is this congruent to the distance from B to D. Let's look at the next page. All right, so let's use this idea. In example 2, it says a shelf fitting into a cupboard in the corner of a kitchen is an isosceles trapezoid. So as soon as we're told it's an isosceles trapezoid, I know that this angle and this angle are the same, and this angle and this angle are the same as well. So it says find the measure of angle N, the measure of angle L, and the measure of angle M. So right away, I know angle N is 50 degrees because it's congruent to angle K. And one thing that we talked about in class, and a good idea to know, is that these two angles and these two angles are always going to add up to 180 degrees. So I can say measure of angle L plus 50 degrees is going to equal 180. So if I subtract 50 degrees from both sides, I have the measure of angle L equals 130 degrees. And angle L and angle M are congruent, so I know angle M is also 130 degrees. So you should pause it and try the next one on your own. Okay, so looking at this, the measure of angle C is congruent to the one I've already been given, so that's 135 degrees. And then I know that these two angles, I'll use C and D, they have to add up to 180. So I can do the measure of angle D plus 135 degrees has to equal 180 degrees. Subtract my 135 from both sides. So I have the measure of angle D equals 45 degrees. So I have 45 degrees here for angle D, and then angle A is congruent to angle D because they're touching the same base, so these two are the same. That one is also 45 degrees. The next one here is our mid-segment theorem for trapezoids. So it says the mid-segment of a trapezoid is parallel to each base and its length is 1/2 the sum of the lengths of the bases. So if segment MN is the mid-segment of trapezoid ABCD, then segment MN is parallel to segment AB, and segment MN is parallel to segment CD. And so we can say MN equals 1/2 times the distance from A to B plus the distance from C to D. So let's actually use this. This is example 3. In the diagram, segment MN is the mid-segment of trapezoid PQRS. So we're told right here, MN is the mid-segment. Here's my directions. Find MN. So I know that MN is going to equal 1/2 times the sum of my two bases, the top plus the bottom. So that's 1/2 times 25. So MN equals 12.5, and my units there would be inches. On your own 3 says find MN in the diagram at the right. So here I know MN is still my mid-segment, and it's going to equal 1/2 times the sum of my bases. So 1/2 times 30 plus 12. So MN equals 1/2 of 42, which equals 21, and that would be feet. So there's my answer for both of those. So the mid-segment's pretty easy. You just do 1/2 of the top plus the bottom. Our last shape that we're going to talk about is the kite. A kite is a quadrilateral that has two pairs of consecutive congruent sides. It says the opposite sides may or may not be congruent. Now, one thing I want to point out, here's my opposite sides, okay? If these two were congruent, we would have a rhombus instead of a kite. So we're mostly not going to talk about our opposite sides being congruent because then we would talk about it being a rhombus. So if a quadrilateral is a kite, then its diagonals are going to be perpendicular. This is something we need to remember. So if quadrilateral ABCD is a kite, then segment AC is going to be perpendicular to segment BD. For theorem 819, it says if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So this is another thing to know. And the opposite angles that are going to be congruent, see this angle is between the two different side lengths. This angle is between the two different side lengths. And so these two are the angles that will be congruent. So here, angle A is congruent to angle C, but angle B is not going to be congruent to angle D. So in my diagram, it says find the measure of angle T in the diagram shown at the right. I should say in example 4. So looking at it, it's a kite. I need to identify my two congruent angles. It's those two. I want to find angle T, so that's my unknown. Well, I know angle R is exactly the same. And since it's a quadrilateral, those four angles are going to add up to 360. So I can write 2x plus 70 plus 88 equals 360 degrees. If I subtract my 70 and my 88 from both sides, Those cancel. I have 2x equals 202 degrees. Divide them both by 2, and x equals 101 degrees. And that would be my answer. The last one, you should try and pause the video and try this one on your own. Okay, if you did this, again, this angle and this angle, those are my congruent ones. I want angle G, so I'm going to name that x, and all across from it, angle I is going to be exactly the same. So I can write 2x plus 75 plus 85 equals 360. I'll subtract my 75 and my 85 from both sides. So those cancel. I have 2x equals 200. Divide them both by 2. And x equals 100 degrees. So there's my answer. If you have any questions, please make sure you ask me in class tomorrow, and have a great night.